Hello everyone, my name is CMA Panktivini. Welcome back to CMA Modules. Today we are going to record a video lecture on topic known as assignment techniques. Let us try to understand this topic in a layman language first with the help of an example. So suppose I am running a departmental store and this store has a vacancy of 3 employees. One is in salesman area, another one is with delivery boy and another one is in cash counter. So I'll have to hunt for people and accordingly I'll have to assign them to respected jobs. So same thing we will be doing here as well. Okay, same thing we will be doing here. We will have sums of different types. Assigning salesperson, salesman to different jobs. Assigning batsmen to different batting positions, areas, different types of questions they'll be asking here. But the basic agenda, basic solving pattern will remain same. Now, you will have two types of questions here. First one is minimization and next one is maximization. So what is minimization? Minimization means directly you can start with a row operation and column operation. But what is maximization? You'll have one additional step here. Other than this additional step, everything is same. How to identify problem is minimization or maximization? So they'll give you words such as minimum, maximum, loss, profit. Okay, they'll give you such type of words. If they give you such type of words, then you identify them accordingly and go for your operations. So if it is maximum, there is only one different step. Okay, one additional step rather, and that step will take in our second lecture. Now I will be concentrating on minimization problems. I'll be taking one problem related to minimization under this lecture. And accordingly, we'll go for different steps, row operation, column operation. Okay. After this, what is my next point is, next checkpoint, I have second checkpoint is, I'll be checking whether my number of columns is equal to number of rows. My number of columns is equal to number of rows. Okay. So suppose my number of columns are 6. I should have 6 rows. If my number of columns are 5, I should have 5 rows. So if given this question is a balanced one. There are 5 columns, 5 rows. 5 columns, 5 rows. But suppose if you have additional row here, okay, row is horizontal, column is vertical. You have L in spelling of column. It is standing. So column is also standing. So you have additional things here. If suppose you have additional row here, then you add one more column. You add one more column, that is dummy column, and make it a balanced one. Okay, and make it a balanced one. So what is balanced? Number of rows are equal to number of columns. That is balanced. If number of rows are not equal to number of columns, that is unbalanced. So this is your second checkpoint. As soon as you read your question, you are supposed to check these two items here. Okay. After that, let me give a read to the question and start with the question. A salesman has to visit 5 cities A, B, C, D and E. The intercity distances are tabulated below. Note the distances between two cities need not be same both the ways. The matrix is given. Note further that distances are in kilometers. Okay. If the salesman starts from city A and has to come back to city A, which route would you advise him to take so that total distance traveled by him is minimized? Okay. So here you must have observed the question itself is mentioning minimum. Okay, question itself is mentioning that it is minimum. So to start with, I've solved this question. To start with, we are supposed to, what I have done is I've noted down the question. And after noting down the question, I noted down the question. After noting down the question, here is my question. I went for first operation, that is row operation. So what is row operation? Identify smaller number from each row. Identify smaller number from each row. If you see in my row 1, it is 12. In my row 2, it is 6. Row 10, row C, third row, it is 10. Row D, fourth row, it is 14. So accordingly, I identified my row number of a smaller number in each row. Subtract that smaller number from respective element. 6 from respected element, 10 from respected element. After doing that, I'll get the matrix. Now what you are supposed to do, you are supposed to take column operations. Now for this column operations, what you are supposed to do, again identify smaller number from each column. Okay, identify smaller number from each column. Smaller number from each column and subtract that smaller number from respected element of that column only. Okay, this is your next step. After doing this, go for allocations. That is, give allocations. Allocations means what? Each row, each column, there should be 1 0. Each row, each column, there should be 1 0. So logically, if I see, you are assigning this salesman B to salesman job A. You are assigning C to job D. Okay, that's the logic behind it. So 1 row, 1 column, 1 0. If you are assigning 0 here, this column will be useless and this row will be useless. If you are assigning 0 here, this row will be useless, this column will be useless. Okay. After doing that, you should have zeros and in each row and each column. Now suppose I don't have 0 allocations here in last row and last column. So what I did, I went for improved matrix. How to go for improved matrix? For going for improved matrix, what I did, I drew minimum lines to cover all zeros. Minimum lines to cover all zeros. Okay, these are my lines. Okay, minimum lines. Lines should be vertical and horizontal only. Diagonally lines not allowed. It should be vertical, it should be horizontal. Diagonal lines not allowed. Okay, so I'm drawing minimum, kam se kam, less minimum lines, and I'm covering all zeros. Okay, I'm covering all zeros. After doing that, what I'm supposed to do, I'm supposed to identify any smaller number from uncovered area. See, I've shaded. So shaded part is my uncovered area. What I'm supposed to do, I'm supposed to find out smaller number from uncovered area. Take that number, deduct the smaller number from each element of uncovered area and add that number on intersection. Okay, you have intersection here, you have intersection here, intersection here. So deduct from uncovered area and add to intersecting points. Okay. After doing this, again go for allocations. You will get your answer. Okay. How you will get? See, each row there is 1 0. Each column there is 1 0. No repetitions. Okay. Each row there is 1 0. Each column there is 1 0. After doing this, you will have to go for your final answer. So what is your final answer? See, have a look. This is my final answer. I have noted down this way, my final answer. So A to B. How I'm getting A to B? A to B is A to B. B to E. Here also I have B to E. Here I have C to D. Here also I have noted down C to D. Then what next I have noted down? D to C. So D row, C column. E row A. E row A. Okay. If you can see, I'll show you question again. They had mentioned here that he starts from city A and comes back to city A. If the salesman starts from city A and has to come back to city A, then in this case, okay, whatever the question is asking, we are fulfilling that. He starts from A and he is coming back to A. Okay. Accordingly, I'll note down my distance. I'll get my answer. Okay. So this way we have to solve our assignment techniques. I'll be surely uploading more sums related to assignment techniques from both the subjects operation management and costing for finals and operation management subject for inter. Hope you like this video. You are comfortable with the lecture. Thank you.